Hello again. So in the last video I was discussing the Bitcoin white paper and I dedicated half an hour to this title, and we have seen the importance of each word and how this title describes a system where people may use or serve an electronic cash system which allows people to possess some coins in a complicated system that is self-organized. Okay, so the declarations here are that let's read just the abstract, and then the other paragraphs maybe will not be written with focus on just them, we'll see. But it says a purely peer-to-peer version of electronic cash would allow online payments to be sent directly from one party to another without going through a financial institution. So in a single sentence, we have both the definition and justification for the existence of a peer-to-peer decentralized electronic cash system. So I will say that the beauty of this phrase is not only its double function, but its clearness. So it says a purely peer-to-peer version. So it says purely because it will not conceive any type of intermediary, especially not a financial institution. It will happen online, and it will allow the transaction to happen directly between the parties involved. So it's purely, directly, online. This means that two peers are not they do not have to pass strictly between some specific nodes to arrive to each other. Because in a system where you have institutions, intermediaries, which will allow the transactions, will enable and allow the transactions, let's not just talk about the nature of the institution, but also about the finite nature of these nodes. So not only finite nature, which means that there is a finite number of these nodes which will not be able to serve everybody, but they are not accessible to everybody. Not only in the sense as number, but in as talking about as servability of all people. Not everybody can be served by these nodes. Therefore, it's needed a purely directly peer-to-peer connection between people. This is the goal of such a system. So again, we are not talking about if it's a positive or negative impact. It's just the nature of the system that is being described here. It's a purely peer-to-peer, allowing to send directly from one party to another. So there's the mention of financial institution here, because we have seen in many comments and messages by Satoshi Nakamoto, which many times have a reference to, not to, but against financial institutions, and he has his reasons. Okay, Now, the second statement starts here and goes until here. It says, digital signatures provide part of the solution, but the main benefits are lost if a trusted third party is still required to prevent double spending. Okay, so this is nearly a monologue by Satoshi Nakamoto. It's not anymore a sentence which looks like part of a dialogue, because he's already starting thinking about what are normally the limits of a peer-to-peer electronic cash system, but also a peer-to-peer cash system. Well, in the case of an electronic cash system, a digital signature system provides part of the solution, because with a digital signature system you can use just a public and private key to sign some actions, some files, and by resolving some riddles, you are able to demonstrate the possession of something, of a right, of an asset. And it's precising again, but the main benefits are lost if a trusted third party is still required to prevent double spending. What does mean? That with digital signatures, normally you can just sign something, but you cannot determine the nature of an asset, the veridicity of an asset. There wasn't such a system here. He stated in just one sentence the state of art of the electronic peer-to-peer electronic cash systems of that time. Remember, A, it's an undeterminative article. With this title, Satoshi was saying that this is a new proposal of something that exists in many iterations, many other forms. And he is saying, okay, the other electronic cash system used digital signatures already in some forms. Not all of them, but many of them were already implementing this aspect, which characterizes Bitcoin also. But he says that he's criticizing them, saying that those systems are still required to trust someone, which will be a node in the middle. For example, if you have a pool of coins, yes, you can sign a transaction to make it happen, but who counts all the coins? Who keeps the ledger of all the transactions? This was one of the problems which were not resolved in the previous peer-to-peer electronic cash systems, and he's stating it here. So in these first two sentences, from one side he's criticizing the main used system with the financial institutions, not criticizing but defining that a peer-to-peer a peer-to-peer network which allows electronic cash system to exist needs to be purely peer-to-peer and to allow transaction directly from one party to another. And in this case, he's saying that the current system are not respecting the first sentence. Therefore, here the third sentence. So he, in two statements, he made the point of a whole industry. And with another sentence, he's proposing something, a solution to the double spending problem using a peer-to-peer network. So this paper is a solution to double spending problems using a peer-to-peer network. So peer-to-peer network, we already have seen what does mean. The other peer-to-peer were not working properly because in the end they always needed in any way a third party controlling an aspect of the system. And here is the challenge. We are proposing a solution to something that nobody has still resolved. We will not allow any institution or third party to keep the books. We will avoid double spending just using peer-to-peer. Okay, so people arriving at this point in 2009, when they were seeing this statement here, they were starting like, okay, this guy may not really understand what he's saying and blah, blah, blah. He received a lot of critiques. All the people that started Bitcoin early, they were, first of all, people in trying to inspect this declaration. They arrived here saying, okay, let's see what you have. And this is the phrase that involves, the first challenges that Satoshi had to pass in front of the first critiques. Therefore, we have the network timestamp transaction by hashing, so the network timestamps transactions by hashing them into an ongoing chain of hash-based proof of work, forming a record that cannot be changed without redoing the proof of work. Fourth sentence, he's already describing the solution. So he says the network timestamps transactions by hashing them into an ongoing chain of hash-based proof of work. So this is already a complex statement, which I imagine all the people for the first time, especially when they understood the real meaning of this statement here, they had some they needed some minutes on this statement here, because graphically it's a recursive concept. The network timestamps transactions, and this is kind of clear and elementary. The network, the protocol, the nodes participate in putting a timestamp to each transaction that is being proposed, and they hash the information about the transaction. And then there's an ongoing chain of hash-based proof of work. So the network itself creates a unique a puzzle with a unique solution or I will say, I'm not sure if it mathematically is a unique solution, but what I mean that it's to verify it, you will have only one way to verify it. The system works ongoing, so it never stops. If the network stops, it dies. And it's a chain, which means that each action is connected to one before. It's hash based, hash-based proof of work. So each chain can be controlled and verified backwards and has a unique verifiable path. It doesn't allow you to, it doesn't allow multiple path, ambiguous path to be obtained from the same cube. From I was already talking about cubes. So from the actual state of things, you have a unique path back to the time zero, to the genesis of all the blocks mined. So I'm already using a lot of words which people will need to know. Which means they already know a lot of things about blockchain and Bitcoin. But this paper was published when the word blockchain did not exist or when was not used in the same way. So it's really interesting to see how dense is this phrase and how many implications the word have. So the network timestamps transactions. Transactions are the object and the network is the subject. So the network works on transactions. The network is hashing them into an ongoing chain of hash-based proof of work. Because at each step, the system is creating a hash, which will be then included in information hashed in the step after. And then the step after will hash the information about that previous block of hash. And so going forward, you will have a unique path to get back to the first transaction. So a unique sequence of transaction is possible. To obtain the same sequence of hash and transactions, there is a lot of work put in this by this network on the transactions hashing. Okay, so even if I'm already familiar with all these concepts, I'm impressed by how this phrase is at the same time dense and complex, but at the same time it's a bulletproof sentence. I will try later to see if also with the Chain Labs critical questions about the paper we can find something interesting on seeing how attacking this sentence is really difficult. So yeah, the only thing you can say that these networks needs ongoing operations which can't be stopped. And yeah, maybe this is something that already can raise some warnings in people learning about this white paper for the first time. Yeah, like in 2009, cloud computing and all the computational technology we have today wasn't that mature, or at least it wasn't available to everybody. But as we'll see later, also this aspect of technological markets and technology available to the privates, all these aspects were also included in many of the concepts that had been exposed here. And well, proof of work is the main the main word in this sentence. So hashing, of course, it's important because hash-based proof of work, it's the most important one. Even if you keep out ongoing, the system dies. Therefore, it's impressive how each of these words are 100% relevant. You cannot express the same thing in less words. I mean, maybe you can, it's a challenge. Maybe the word proof of blockchain, proof of work blockchain may say the same thing, or nowadays you may say proof of work network, hash-based proof of work network. But the ongoing, I think it's most undervalued here, in the sense that everybody knows that it's ongoing, of course. It's my main point here, or one of the main points. But at the same time, nobody says the ongoing network of Bitcoin. And yeah, this sentence is so solid. Then the sub-sentence says, forming a record that cannot be changed without redoing the proof of work. So the implication of this network, ongoing network, hash-based proof network, is that it forms the unique sequence that cannot be changed without redoing the proof of work. So if you want to recreate the same sentence sequence but with a slight change, you will need to reuse all the energy that has been used. Well, no, I was saying something really stupid, but you have to, well, there are many ways in which you may be able to, for a slight time, you may be able to change the proof of work sequence of blocks. It's very difficult even to formulate sentences without saying, doing some little errors. I would say little, but maybe they can be also big errors. So choosing the words is really hard. It impressed me again how these sentences instead are perfectly formed. It looks like the work of decades of copywriting. Forming a record that cannot be changed without redoing the proof of work. So this is the implication of this sentence here, which is the opening after this declaration, this challenge declaration. So the opening is a network, an ongoing network based on hashed proof of work. Therefore, in the end, we have this other part. And I will finish this abstract. I will finish this video dedicating time only to the abstract in the end. So I will dedicate some time to these sentences. The longest chain not only serves as proof of sequence of events witnessed, but proof that it came from the largest pool of CPU power. Okay, so this is a nuance, not a nuance, it's a huge aspect, which says that the decisions, the chain of decisions transactions that happened are backed by computational power. In each moment, so the interesting concept here is saying that in each moment with this system, you can be sure that the decision will be taken by the largest pool of computational power. It's interesting to see how it's being used pool here, which is not referred to the mining pools which we have today. Maybe in some other parts they have been predicted here, but at the time the idea was each individual will have I mean, it's not specified, but it's considered, I think, if I'm not wrong, that in this white paper a node potentially coincides with a miner, which today it's something that is not like that. So with pool, we refer to that group of computers which agree on something. So the largest pool of nodes agreeing with each other, the largest pool in terms of computational power, will decide things. And you can be sure about that because of proof of network. Sorry, I'm already tired. Proof of work. So in this network, ongoing, based on a hash-based proof of work, things will be decided in each moment, at each time, at each block, at each transaction block. The decision will be taken by the largest pool of computational power. This is a really interesting sentence because it's treating the computational power and the proof of work in a double way. It's treating it as subject and as result. The meaning of this is that the proof of sequence is the main thing which you may search when looking at the blockchain history. But the real thing which exists, its underlying existing, is the history of computational power. So this is a chain which is a proof of computational power distribution. And as a result, and this a history of distribution of computational power, which always allows the biggest pool of computational power to take decisions. Therefore, as you have the history of this computational power distribution, you will have the sequence of events witnessed. But to say it, there's a nuance. You have the story of distribution of computational power, but a story that looks only to the strongest pool, to the largest pool. I will say the strongest, well, here is the largest pool in terms of computational power. I will just say the strongest pool. So you have this sequence which says who has been the strongest. And the strongest gets a reward, as we'll see later. By knowing this series of rewards, by knowing the series of who has been the strongest, yeah, maybe largest is better. Larger is better. Forgot strong, because you will see why large is better. I will mention it. Sorry, but larger is better than stronger. So another time, incredible choice of words. It's better to use larger. I will discuss it now, so I don't forget it, because larger implies probabilities. Being the stronger doesn't necessarily allow you to win the competition in the network, the proof of work competition. Being the largest augments your probabilities. So sorry, but I was thinking while talking. Therefore, you have the story of the largest pool of computational power, and with it you have a history of events witnessed. It's like history is written by winners. Therefore, the history we know is the sequence of books and things that has been transmitted by the winner's propaganda. So each winner, after winning a war, will say how they won the war. This is an analogy. I'm not sure. I will explore it more, but for now it looks like an interesting analogy with the hash-based proof of work network. Because during exploring the history, you can be sure that that has been written by the winners. So this is a really interesting phrase. As you can see, it has a lot of interesting words, and it can be really, there's a lot to say in exploring it. Therefore, then we have, as long as majority of CPU power is controlled by nodes that are not cooperating to attack the network, they generate the longest chain and outpace attackers. So here we have the chain as goal, as a system which comprehends attackers and defenders, or honest and malicious agents. So we have the network, which it's like a universe which comprehends both type of actors. Okay, therefore it's being said here that if the largest pool of CPU power in the network pertains to, it's formed by nodes which do not want to attack the network, which are not cooperating to attack the network. It's an interesting way to say it, because now I had an interesting point of view on it. Because from this point of view, I'm seeing that in theory, game theory, you have these goals that can be achieved only if the players are cooperating. And many times the reward from these cooperations surpass the cost to cooperate. And this is the case. To destroy this network, to make it not working properly as expected, you need to cooperate. And we'll see why. Because you have to generate the longest chain and outpace attackers. Outpace defenders, but yeah, here it's saying the positive version of the same phrase. They'll generate the longest chain and outpace attackers. The honest nodes will generate the longest chain and outpace attackers. So the honest players, as long as the bad actors are not cooperating, and the honest actors are in majority, they are the largest pool of computational power, they will generate the longest chain and outpace attackers. At each time, we can imagine that there are two chains of truth, two chains of proof of work events, two chains of transactions. At each time, these we can imagine even more than two. We can imagine like 10 possible chains. There will be only one of these chains that will progress and will be extended by another block. Therefore, it will begin the longest chain, and this decision is made by the largest pool of computational power. They decide which chain to extend. This power to decide which chain to extend automatically wastes all the effort on the other chains. This means that while you're attacking, you may have the power to extend the chain until the block 10, until the 10th transaction. Well, blocks are formed by transactions, so this is not a good way to say it. But yeah, you can extend a chain with 3 blocks, 4 blocks, 5, 10 blocks. But as soon as another chain gets longer than yours, all that chain will be trashed. Therefore, even if you have power to build a chain, it has to be the longest, to be the one that everybody considers the right one. Therefore, this is why he says forming a record that cannot be changed without redoing the proof of work. Because everybody considers the longest chain the one that is true, the one that has been built by the largest pool of computational power. So here we have some technical details saying that the network itself requires minimal structure. Messages are broadcast on a best effort basis, and nodes can leave and rejoin the network at will. Here we have one of the characteristics of peer-to-peer. You can contribute to the network. You do not have any obligation. Therefore, the messages have these characteristics. The node can leave and rejoin. And so the nodes can leave and rejoin at condition that when they rejoin, they will have to accept the longest proof of work chain as proof of what happened while they were gone. So you can get out of the game for a while, then you can rejoin, but it has a cost. You will need to relearn all the history while you have been away, so you cannot just join in any moment. We'll see that in some cases this is possible, but with other let's say renouncing to other aspects, to other values. Therefore, we spent another half an hour only on the abstract, which has a lot, is so dense, especially these phrases here. These three statements, are they three? I think so. They are so dense. You can write books and books only about these three sentences. So it's saying, first of all, the nature of the system, the implication of relying on computational power as demonstration of proof of work demonstration, and the game theory hypothesis, which is at the base, at the real core of everything. I will say that this is like maybe in the abstract, for me in this moment, in this part of my learning path in Bitcoin, this is the most important sentence for me in this moment, because I decided to work on this project. And when you decide to work, it's because you really accept that this sentence here works. For me, deciding to work, to dedicate time to the Bitcoin repository, to Bitcoin core repository, but in general to all the Bitcoin environment, the concept behind this sentence, or maybe not so behind, because it's like so explicit, but at the same time it implies a lot. So this concept of cooperation game theory, which is at the base of what is emerging as a behavior in this incredible network, this is why I decided to work on it. This is why I decided that it's worth investing energy on it. Because for the last 15 years, it demonstrated that this statement works, and there are many things which normally require cooperation to keep them alive, many good things. In this case, it's a paradox, because cooperation and effort, because of historical reasons, sociological reasons, economical, financial reasons, because of a chain of historical events, this statement is so strong, because for the first time there's a system in which attackers will need to cooperate to destroy something, and they're the malicious side of things. Of course, this is said from the point of view of a honest node in the system, because I don't know, maybe in the future it will be moral to attack Bitcoin, who knows. Nowadays I will say that it's moral and it helps society to be a honest node and to help to put computational power in extending the longest chain that outpace attackers, that outpace centralization actors which may be interested in attacking some way this system. Nowadays the attacks are not on the computational power side, are more on they're more on financial layers, political layers. Currently, the dangerous, or I wouldn't say dangerous, but the thing that is trying to not leave Bitcoiners alone is trying to create some political incentives that will allow people to use Bitcoin, but at some alien condition, alien to this white paper, alien to what is the network made for, alien conditions created by who has to lose about this, or alien conditions by those who were already gaining a lot on the backs of other people, and they're in position to gain a lot also from this system. But yeah, this statement allowed us to arrive to where we are today, where the network is it's facing these enormous challenges that no other networks, no other movement arrived to a point like this one. It's so interesting from this historical and sociological point of view, and I think that a lot is due to this statement, which in this case, in this document, is just a statement, but in real life is game theory showing itself. Yeah, it's like, how is called the guy from the game theory economics? John Nash, right? Yeah. So this guy here, so yeah, Carnot was a French philosopher and mathematician, which with other people laid the idea, which then has been exposed by John Nash. Wow, it's so strange that I do not have a Nash link here. Ah, okay, John Forbes Nash. So this guy here describes some mechanism which will be involved when considering an adversarial system where some good actors, human actors, and bad human actors are involved and have different interests. Well, this statement here is using some concept and ideas from this framework described by John Nash. And for me, it's one of the most important things in this paper and in trying to understand what is this network doing, what is happening, why it's so strong, resisting China's ban, United States ban, all other countries which try to ban, limit it, or imitate it. Many cases, states and corporations try to imitate this system, but they could not imitate it because they were lacking one of these words here. Words are so important, and even if as a writer one may be fascinated by this abstract, and of course I imagine all the paper is it has the same quality, but it's a really nice and funny exercise from a literary point of view to try to consider each word, to try to see the definition, the role of that word in this statement. And many times I've seen that Satoshi had these really fine, refined statements where one concept will be the object, but also will have another role, logical role in in the sentence. There's such a mastery in this. There's such a quality. Of course, there are some people saying that Satoshi is not just one person, maybe CIA, NSA, maybe another group of people, cypherpunks, maybe everybody, everything. It doesn't change the quality of this abstract. It doesn't change what happened and how incredible is everything what is happening in this system, in this peer-to-peer electronic cash system history. So I will stop here, as we already have nearly an hour just talking about the abstract. Therefore, thank you very much, and